Just trying to exit that window. Do you want to create out that?
Should I get my headphones so they can hear better?
Yeah, I think so. It's fine. Alright, so
Sorry? Okay. Can you check if you can hear me? Hello? All right, so I guess we will start. My name is Guy. I'm the data engineer at Hydrogen and machine learning person. I would love to get you guys feedback on our new product called Ion, which is an AutoML API. I would love to answer your questions about it. So the way this is going to work is I'm going to go through briefly what AutoML is, and then some of the challenges, and then I'll show a demo of the API. And I have Sabi here who will be looking at your questions and fielding them for me. All right, then let's get started. So Ion essentially is a set of cache algorithms which optimize machine learning models. The models that we use are in H2O and scikit-learn, and we're going to add more open source packages, integrate more open source packages as we can. And the goal is to automate the machine learning process so that you can power your applications with machine learning with very limited interaction. So we call the applications that are injected with machine learning as ionized products because ion is supercharging them. So very quickly, we'll discuss what machine learning is. I'm assuming that the people on this live stream have an idea of what machine learning is, so it'll be very quick. So essentially, machine learning is about approximating functions. So we have an input X and we have a desired output Y. In regular programming, you would just write an algorithm to take the input and transform it into the output. That algorithm requires careful design and programming, but it's exact. In machine learning, on the other hand, you take examples of the input and examples of the output, and the result of the machine learning process is an approximate algorithm or approximate function that is doing what you want it to do. So I'm going to skip this so that we can get to some of the examples. But basically, AutoML is essentially the process of choosing a machine learning algorithm and then doing hyperparameter optimization on that machine learning algorithm to find the best possible approximation to your function. So some of the open source libraries that provide these types of algorithms, there's AutoSKLearn or scikit-learn. There's H2O's AutoML. There are others. Those are the two that I think are making good progress. So why is it not enough to just optimize your machine learning algorithms? There's a gap between getting your data ready for the machine learning algorithm and then feeding it in and doing this hyperparameter optimization and AutoML, and then also getting those predictions to actually power your app. So there's a big gap there. And so if we look at what Ion is doing, essentially it's trying to automate a small part of the machine learning or data science process. There's still a lot of feature extraction, data collection that needs to be performed. And that's something that we're also working on automating, and other systems are working on automating to make these AutoMLs actually usable. So some examples of real-world AutoML. Google recently released this AutoML Vision, which focuses on automatically detecting products and images or classification on images. So they're basically saying, all right, let's standardize the input to be images, and then we'll do machine learning on images. Salesforce has is about to open source their framework for doing AutoML called Optimus Prime, and its focus is more on customer CRM data. So trying to predict which leads are promising or things like that. They claim that 80% of their models, or the majority of their models, are fitted without any human intervention. So that would be an ideal state. To our knowledge, there's not any AutoML products for financial applications, and I think there's a few reasons for that. The first reason is that financial data tends to consist of time series, and there's correlation between the observations. So any model or AutoML process has to take that correlation into account. And as a result of that, the sampling when you're fitting and optimizing and doing the AutoML needs to take that correlation into account. And there aren't even cache algorithms, let alone the general AutoML framework for time series models. So what we're looking at to do with Ion, so for the traditional machine learning, meaning non-time series, we're looking to integrate other frameworks like Spark and TensorFlow and any open source machine learning packages that are useful. And then the other thing we're looking for is to build out some of that automated feature extraction. So try to specialize our AutoML system a bit for specific applications to make it useful. On the financial machine learning side, we're working on building out the infrastructure to do the sampling of time series correctly, which will then enable us to extend our AutoML and hyperparameter optimization algorithms to time series models. And then, of course, the next step for financial time series, we still have that issue of automated feature extraction and building time-based features, just like we have for traditional machine learning. So this is something where we would like to get feedback from you. We want to know which kind of machine learning challenges you are facing and it would benefit from automation. So if we want to stop here and ask questions, or I can go I'll go directly to the example. So, okay, so for the example, I'm going to focus on a data set that's very familiar to a lot of data science machine learning people, which is the iris data set. It's usually the hello world of machine learning. And I'm doing this not because I want to show such great performance, but to really show how what the workflow in Ion looks like. So a brief description of the data set. There's 3 types of flowers that are recorded in this data set. And for every flower, they record the sepal length and sepal width and petal length and petal width of these flowers. And the goal is to predict which flower the attributes belong to. So for the first row, we can see the flower has a sepal length of 5.1, sepal width of 3.5, petal length of 1.4, petal width of 0.2, and the type of flower it is the iris setosa. So ideally, we'd like a function that goes from the sepal, takes in sepal length, width, petal length, and petal width, and then gives us the type of flower. So the first thing we have to do is get access to Ion through an OAuth endpoint. And so we do this by posting a username and password. So we set up the username and password, and we make a post request to the OAuth endpoint, which then gives us the token. Now we attach this token to every header request that we hit with the Ion API so that we know that we're approved, that we have access. Next, we're going to post dataset metadata so that Ion knows where data is and it can load it into memory for machine learning. So one thing about Ion is that it's not really storing the data anywhere. It's just loading into memory and doing the machine learning, fitting machine learning models. And once the fitting process is done, the only thing that's stored is the model and hyperparameters. So here's an example of a post request. I'm specifying the location, the column name, because in this case, the file did not have any column names in the CSV. And that's why I'm also specifying is header is false. So it's not looking for the column names in the first row. What I get back in return is a dataset ID, which I can then use to get the status of that data set to see that it's stored. We can also hit the dataset endpoint and set a parameter of head equals 5, and it will show us the first 5 rows of the dataset to make sure that Ion can load it and it's loading it in the right way. So next, we're going to post an AutoML job to an AutoML endpoint. So in the AutoML job, we're going to post a dataset ID. We're going to specify the type of AutoML. In this case, it's a classification because we're trying to decide between 3 types of flowers. So it's a classification problem. The target column in the dataset was named class. That's something that we have to provide. The percent test is the percent we're going to split our dataset into a training and test dataset. This is saying it's 20% of the test dataset. And most importantly, we have a time limit, so we're not going to give you the ability to run AutoML forever to find the best model. We're going to set a time limit, and once we reach that time limit, it's going to return the best model it found so far. So when you post a job, it doesn't actually start it. It just creates the metadata. In order to actually start the job, you have to send, you use a GET request on the AutoML endpoint with the AutoML ID, and you say command equals start. Once it's started, you can get the status, and this is something that you would see as a result. So you would see the status of running, and it has all the metadata that we use to create the job, and you would see a progress of 27%. Once it's done, you're going to get a whole lot of output that we're going to go through momentarily, but basically this is what you'll get: a success status. So you could write in your code, check the status until status equals success, and then get the result. So the duration is 76 seconds. We specified a limit of 60 seconds. The reason it takes longer than that is there's additional saving the model and other things that the algorithm takes into account. So that time limit is really on the optimization and not on the overall process. So one thing we get out of the AutoML job is predictions. So we will have, there's a slight lag, my apologies. So one thing that we get out of it is predictions. So remember that we split our data set into training and test. And so in order to get the predictions for train, it will be in the JSON format when the entry AutoML, result, predictions, and train. So in order to know which rows those predictions correspond to, you would get the indices for the training data set. So for row 1, it's predicting iris setosa. For row 2, it's predicting iris setosa. So basically for the first set of rows, it's predicting iris setosa, and also for the test index. But you can see that the test and training indices don't overlap at all. We're completely separated. The next thing we get is metrics. So get some machine learning metrics. The log loss is what we use to fit the model. And so here, lower is better. We split out the metrics into the cross-validation metrics, which were used to find the optimal hyperparameters, and then the test metric, which was a data set that was completely held off from the entire process and only used at the end to evaluate the model or evaluate the machine learning workflow. So we optionally have the option to take the optimized workflow now and evaluate it on a new test data set. So we can get the optimized workflow ID from the AutoML job, and then we can post an evaluation job. And so the evaluation job takes in a data set and the optimized workflow ID, And in return, we'll give you the predictions and metrics for that particular data set. And so we do that by posting to the evaluate endpoint, which then gives us an evaluate ID. Like before, posting does not actually start the job. So we have to send a GET request to the evaluate endpoint to actually start the job. And then we can check on its status by using the status command on that same endpoint. So like before, we get predictions. So here there's only a test prediction because for evaluate there was no training. We're simply testing the model on a new data set. We also have the metrics. Again, we would only have metrics for test because this is what evaluate means. We're only evaluating the model on a single test data set. So this AutoML is great. And it did a lot of the feature engineering automatically. Now, sometimes if you have more data science expertise, you might want to do some of the data processing on your own. For that, we created a workflow endpoint. And so the workflow endpoint is basically composed of 4 parts. The first is a data set, which is specified by a data set ID. Next, you specify a target pipeline, which prepares the target column for machine learning. And I'll go through an example of that in a second. The third is the feature pipeline, which transforms the inputs to features that are going to be fed into the machine learning process. And then finally, there's a model pipeline, which is what we're actually going to optimize. So to see all the different components that can be put into the pipeline, we can hit the model endpoint and see some of the models. So this is what a workflow looks like in JSON format. There's a slight lag, so I'll wait. So as you can see, it's just JSON. The target pipeline is a list of models. The feature pipeline is a list of models, and I'll explain why in a second. And then there's a model pipeline, which is also a list of models. So in more detail, the target pipeline here uses a data frame selector model to select out a specific column. And then it does categorical encoding, meaning it takes those labels, which were iris setosa, iris, all the different text, and it turns it into numbers because we need them to be numbers for the machine learning to work. The feature pipeline, since all the attributes were numeric, there is no really pre-processing that we need to do. We can just feed them into the machine learning model. You could specify other ways of processing the features before they get to the machine learning pipeline or the model pipeline. But for this data set, it's a very simple one. And we're not going to do any pre-processing on the features. And then the model pipeline, we specify the classifier predictor or any other pre-processing steps you wanted to do. So for example, you could also have CCA or some other pre-processing or imputation to fill in missing values. You could add more steps to this pipeline by putting more JSON in this list. So as an example of what these pipelines do, let's look at the target pipeline. So initially we had this class column, which was all text. And then we said we're going to use the categorical encoder. So essentially what this does is it takes this text and it transforms it by mapping each class to a number from 0 to 2 because there are 3 different classes. And so the output on the bottom here is the result of fitting and using that target pipeline. So this is what's going to be fed into the machine learning model. So next we would post the workflow. And when you get the workflow, it will return basically what you gave back, plus the default parameters that you didn't specify. It'll tell you what is set initially. So next, we want to optimize that workflow. So we're going to post an optimized job to the optimized endpoint. So we have a workflow ID, which we just posted. We have a %test, just like in AutoML, we're going to split up the data set into training and test, and this is saying 20% test. The random state here lets you fix the process of splitting up the training and test so that your experiment is repeatable. We also have that on the AutoML endpoint. I didn't specify it, but by default, it will be random. But the AutoML job will return the state that it used so that you could repeat it if you wanted to. The optimization type is a grid optimization. So it's going to look through all the hyperparameters for this model and try to find the best one. Alternatives are random and Bayesian. I can get into more detail on that if people want more detail. And just like before, when you post a job, it doesn't actually start it. So in order to start it, we have to use a get command on the optimized endpoint with command equals start. And then once it's started, we can check its status, which will give us the progress. I'm gonna wait for the video to catch up a little. Oh no, it's caught up. And then once it's done, we're gonna get a whole lot of output, just like we did on the AutoML. So we really designed the output for these endpoints to correspond. So the stuff that you get out of Optimize is the same thing that you would get out of AutoML. The essential distinction is that for Optimize, you're specifying which machine learning model you want to use. And for AutoML, it's going to choose for you. So just like AutoML, we'll get the predictions for the training and the test, and we'll get the indices so you know which rows they correspond to. And we also get metrics for the cross-validation, which is like the training metric, and then the test metric. We also get an optimized workflow IT, which we could then optionally use, just like we did with the AutoML. We could hit the evaluate endpoint and test this model on a new test data set. But keep in mind, this new test data set has to have the same columns as your training data set. Otherwise, you'll get an error. So that basically concludes the example or walkthrough of how working with Ion, the workflow with Ion. I'd be interested in taking any questions or if you have any feedback on, for example, if there's something in the output that you didn't see and you would like to see, if there's some formats that are like data formats that you work with commonly that, aside from CSV, that you would like to see us handle, that would be valuable input as well.
So we have a question, which is, what is Ion used for?
Okay, so Ion is really about automating the process of fitting a machine learning model. Now, it's too general to be useful for a lot of things. And so what we're working on now is specializing the machine learning process to fit for a specific application. So you can imagine, for example, fraud detection, where we have transaction data and we want to fit a machine learning model to detect fraud, and we're getting new data all the time, and we want to update our models. Ion could take that data and automatically fit a new model as new data is coming in.
So another person asked, what is your competitive advantage among similar projects out in the market?
So that's a good question. I'll repeat the question just in case. The question was, what is our competitive advantage compared to others in the market? So there's two things here. First, we're not really competing with anybody. H2O, as I said, has an AutoML process. There are plenty of open source libraries that are doing AutoML. We're really looking to integrate with them, not compete with them. So we want to unify and get all the possible modeling techniques under one API. The other thing is that these other frameworks are not really providing the compute power. And so right now, at least in the beta stages, we're offering free machine learning, essentially, or free AutoML that are fitted on our cloud platform.
I believe that's all the questions we have right now from everyone on the screen. I guess now is the time for anyone else to ask any questions they may have, or whom they may not understand, or any feedback they would like to provide.
Yeah, so we'd like, if anybody has any additional feedback, we'd love to hear it. Or if you have any questions, if something wasn't clear, we can go back, or if you want to know more detail about the algorithms, we can talk about that. Anything you would like to ask.
Great, so I think there are no further questions. I'd like to take some time to watch our demo, and if you have any questions, feel free to contact the hydrogen team. And if you would like to participate in the beta testing for our API, you can sign up for a beta key on our website.
Yeah, so to reiterate, thank you very much for joining us. If you want to test Ion out, you can request a beta key on our website. Again, we'd like as many people as possible to test it and to give us feedback. So we very much appreciate your attendance and questions.
So we have another question that someone has, which is, do we build our algorithms on existing frameworks such as Pandas?
So yes, we do. We're using open source packages. And so really what Ion focuses on is on hyperparameter optimization and automating the feature extraction and model selection process. Like I said, we want to integrate with as many open source packages as possible. We're working on integrating Spark as well as Pandas data frames. Yeah, any technology that you guys think is useful that you're using in your work, we would like to know about so that to evaluate to see if we can fit it into the Ion.
So I think that was the last question we had. So thank you for joining us, and end the screen right here, and keep an eye out for any other hydro-related webinars or podcasts.
All right, thank you very much for joining us. We will keep an eye out on the live stream and our Twitter and all our contact information for any other live streams or meetups. Yeah, thank you. I think, and we'll end it here. Thanks.